Hello. In this video, we're going to discuss about the strategy to find the integral solutions of a particular equation, which we call the Diophantine equations. So over here, the equation marked as 1 is a particular equation, and we need to find the integral solutions of this particular equation. So what do we do? As defined in the second step, we simply factorize this particular equation defined as 1. So we get x minus root 2 times y times x plus root 2 times y equals to 1, as defined in the equation number 2. In equation number 3, the step 3 that I have defined as step 3, I have defined a set of integers as alpha, which represents the integers which are of the form x plus root 2 times y. Yes, I am calling them integers, and beta as x minus root 2 times y. In the fourth step, I have defined a particular property which these elements follow. That is alpha raised to the power of n, that will be equal to x plus root 2 times y raised to the power of n, will give us something which also belongs to set A. It means that we'll get an integer or an element which is of the form p plus root 2 times q. Similarly for the equation number 5. So why is it so? We can simply prove that if the equation number 4 is known to us, we can clearly find out equation number 5 by doing the binomial expansion. In the equation number 6, I have simply multiplied a raised to the power of n and b raised to the power of n, which gives us something like p square minus 2q square. So if we consider equation number 1, that will actually be 1 raised to the power of n, which is equal to 1. So we can clearly see that for any n which belongs to a natural number, the equation holds true. So how do we get the values of this p and q? Over here, if we put n equals to 1, we'll get alpha raised to the power of n as alpha raised to the power of 1, which is x plus root 2 times y raised to the power of 1, which is equals to p plus root 2 times q. The next step that we have to do is to find trivial solution. Now what do we mean by trivial solutions? We need to find the simplest possible solutions to this particular equation. You can clearly see that the negative values actually doesn't matter. I have taken all the positive values. You can obviously take the negative values as well, because it is x squared and y squared. The negative sign actually doesn't matter. I have taken the integer solutions as the natural solutions. So over here the trivial solutions are 3 and 2. As you can see, 3 squared is 9 and minus 2 times 2 squared, that is 8. So 9 minus 8 is 1. So that is a particular trivial solution. Now if we compare this solution with equation number 7 as p plus root 2 times q, we will get to see that p plus root 2 times q is actually equal to 3 plus root 2 times 2. So from there we can say that p equals to 3 and q equals to 2 just by comparing both the equations. So over here, as you can see, that if we keep on incrementing the values of n, because n belongs to all the natural numbers, if we keep on incrementing the values of n, we will get elements which are of the form p plus root 2 times q. So for n equals to 1, we get x equals to 3 and y equals to 2. Now if we increment that by 1, we will get n equals to 2, that is 3 plus 2 times root 2 raised to the power of 2, and that will be 17 plus 12 root 2. So we get another solution, that is x equals to 17 and y equals to 12. So in this way we can get more and more integral solutions as we keep on incrementing the values of n. For n equals to 3, then n equals to 4, and so on. So in this way we can find more and more integral solutions which actually satisfy this particular equation, which is defined as the equation number 1. So that's all in this video. Thanks for watching, and if you enjoy And if you have enjoyed this watching this video, then please like and subscribe to my channel for more such videos. Thank you.